All right, so we went above and beyond what is being requested of us with the first one, and named 3 central angles, ACB and BCD and ACD. Those are 3 central angles. Their vertex is on the center. A major arc has to be greater than 180 degrees. We use 3 letters to represent it and an arc shape over those 3 letters to show that we are talking about an arc. Minor arcs have to be less than 180. So let me give you a couple of minor arcs here. Let's go, and we only need 2 letters to represent a minor arc. Less than 180. So DB would be a minor arc. His central angle is less than 180. See how the central angle is smaller than 180? AB would also be another minor arc. And then a semicircle. A semicircle is, its central angle is equal to 180. And there's only one here. And we need, I guess it doesn't matter. It actually does. So if I told you central angle ABD, or it would give you this semicircle, ABD, thank you, dyslexia, versus semicircle AD, could be either the top semicircle or the bottom semicircle. So we're going to be specific. We're going to use 3 letters. We're going to say ABD to represent that bottom semicircle. All right, so Nick, can you read the definition of arc measure for us? Just do the minor, and then we'll have Danny do major.
The measure of the minor arc is equal to the measure of its corresponding central angle.
So we're going to make life simple for us. Whatever the central angle is, so in this picture it's 50, we're going to say that the arc measure is also 50. So we're going to do same to same. Whatever the central angle is, the measure of that arc is also going to be 50. All right, Danny, will you read major arc?
The measure of a major arc is the measure of the related minor arc subtracted from 360.
So if I wanted to find major arc, RQT, I would take 360 minus this little guy, RT, 50, and get 310. So 360 minus 50 is 310. So if you're asked to find a major arc, all you have to do is subtract out the minor arc, and it's going to be equal to the arc. All right, so let's do some problems using that information. We want to find the measure of each arc, and yes, it is as simple as it looks. So, Lexi, PR is this guy right here. What is the measure of PR's central angle? Halfway around the circle.
360.
Half of that.
No. 180.
So it's 180. So the measure of our PR is 180. Now, Stevie, RS is this little guy right here. What is his measure? 60. It is as easy as it looks. Sam, help us out with PQR. Also 180. sorry, PRQ. Okay, so PQR is 180, so I'm moving that down. So I said it wrong. You said it. You did it right. I said it wrong. Damien, that means you get PRQ. P to the R to the Q. So follow the path P to the R to the Q.
140.
P to the R is 180. And then to the Q,
320.
how do you know? Because somebody yelled it and I just yelled it too. Don't go with that. The worst way to cheat. Okay. So we're going to subtract out. So Damien, do you see how PQ is not along our pathway P to the R to the Q? So we're going to subtract out that 40 from the 360 because it's 360 all the way around, but we're not going all the way around. We're stopping 40 short of that. Okay, so 360 minus 40 is 320. All right. Right, that was here. All right, so let's ready to make it a little bit more complicated. Not too much, just a little. Not too much, just a smidge. But it's okay, because it's not like circumference is brand new newsies. We've been doing circumference for a long time. Okay, so on our polygon problems, we were talking about perimeters. For the circle, the perimeter is the circumference. I'm going to move this down so you guys can see a little better. So the circumference of a circle is 2 times pi times the radius of our circle, or pi times the diameter. And don't forget, twice the radius is equal to the diameter. And just for fun, the number pi is irrational. Does anybody remember what irrational means, Jeff?
You can't write it as a fraction.
Can't write it as fraction, and the decimal never ends. It goes on forever. So irrational number goes on forever. Can't write it as fraction. All right, so let me tell you why all circles are similar. So to be a similar, we did polygons. To be a similar polygons, all your side lengths have to be proportional. So if we look at circumference is equal to pi times the diameter. If I were to solve for pi, and this is what we make all of our pre-algebra students do when they're learning to solve equations. We just for fun make them solve for pi. Pi is equal to circumference divided by the diameter. No matter which circle you pick, the circumference of that circle divided by its diameter is always going to be equal to pi. So because that proportion is the same, the proportion for every circle is circumference divided by diameter is always going to be the same ratio of 3.14 approximately. So that's why all circles are similar. Just for fun. All right, so it's not enough just to know the arc measure. We need to know that length of our arc. So what we're going to do is we're going to take our circumference and multiply it by whatever fraction of the circle we have. So if I have 45 degrees as a central angle, I'm only taking 45 degrees of the turn around our circle. We're going to take that 45 divided by 360 and then multiply it by the circumference. So sometimes we are not traveling all the way around the world. We're just going part way, like from California to New York. Not all the way around, just a part around the world. Okay, so if we look at example 2, we are going from A to B, so California to New York. We know for some reason, we know that it's 36 degrees for our central angle. So the measure of our arc length from A to B is 36 degrees. So we're going to put it into this formula. We're going to say 36 degrees over 360 times 2 times pi times r. So we got the 2, that's for sure, the pi, that's for sure, and the radius of our tiny, tiny baby Earth here is 5 centimeters. Super small planet. All right, watch what happens when we simplify this. 36 divided by 360 is 1 over 10. 2 pi times 5 is 10 pi. 10 divided by 10 is 1. So the length from here to here is pi, or approximately 3.14 centimeters. So if I were to walk from A to B, I'd walk all of 3.14 centimeters and then stop. Okay, and yes, it is as easy as it seems. Okay, so from E to F is 100 degrees out of 360. Then we're going to multiply that by the circumference of our circle, so all the way around is 2 pi times 7. 10 over 360, well, we can get rid of one of the zeros on the top and the bottom. Half of 10 is 5. Half of 36 is 18. 2 times pi times 7 is 14 pi. 2 goes into 14 7 times. And 2 goes into 18 9 times. 7 times 5 is 35. So that's 35 pi over 9, which is approximately, so if I'm walking from E to F, quite a long ways around my world, that's going to approximately be equal to 12.2 meters. Okay, so take a look. Lane 1, I have to recap for the camera. 2 pi times 29 plus 2 straightaways, which is 108.9 plus 108.9, give us approximately 400 meters. When we look at lane 2, we add 1.25 to the radius. So instead of 29, we have 30.25. So pi times 2 times 30.25 plus our straightaways gives us about 407.9 meters. All right, so think about this. If you are in a car, so however you travel today, sometimes I walk to school, but today I traveled in my car. If you're in your car, when your tire spins around one time, you have traveled the circumference of your tire. So whatever your circumference of your car tire is. So if you have a big tire, spinning around once will take you further than if you have a smaller tire. So every time your tire spins around once, you travel the distance of the circumference. It's pretty cool to think about. So in problem number 4, a tire has a rim diameter of 17 inches, so that is all the way across. is 17. And the sidewall width of the tire is 4.33 inches. How many revolutions will the tire make when you travel 100 feet? The first thing we need to do is cut this 17 in half. Half of 17. 8.5 because half of 16 is 8. So my total radius is going to be 8.5 plus 4.33. And that gives us 12.83 inches. So my tire, when it revolves one time, will travel whatever 2 times pi times 12.83. 2 times pi 12.83. That's 80.6 inches. So one revolution takes me 80.6 inches from start to finish. How many feet is that? I only ask because we want to know 100 feet, and we're in inches here, so we got to resolve that issue. How do we go from inches to feet? Yeah, divide by 12. So 80.6 inches divided by 12 is 6.7 feet. So one revolution, one rev, takes me 6.7 feet. Yay, pretty decent. So 100 feet divided by 6.7 will tell me how many times I have to spin around to get to 100 feet. So it's 100 divided by 6.7. I'm going to round that up to the nearest whole revolution and say that's 15 revolutions. So one cool thing about circles is we think of it in terms of circumference. When we come back on Monday, we will finish 10.7. We will do Chapter 10 review and performance tasks the first block day, and then we will do Chapter 10 test next Friday. Guys, go ahead and get out a piece of paper. We're going to spend the next 7 minutes practicing the first couple of practice problems. If you need a paper, you can go ahead and grab one. I have blank pieces of paper on the back table. You guys can grab one. We want to start on page 654. Don't forget to do origami paper folding. And then, Madeline, if you can show Kate how we do origami paper folding for our practice, that'd be awesome. Okay, guys, we're going to combine our 10 10-5 worksheet practice and our 10-6 practice. In about 5 minutes, I'm going to ask you to give me your score on a 4-point rubric. 4 meaning you worked the entire time. 3 being you were off, like more than a couple minutes off task. 2 meaning you had your phone out at all without permission. 1 is you just kind of sat there but at least got one problem done. 0 means nothing happened during that practice time. You guys are going to report your score to me. I think you can get 9 through 11 easy done, and at least problem number 12 in the next 5 minutes. Then we're going to hold on to this paper and start.
Where's your paper?
Oh, you